Hey everyone, it's Mr. Morris again. We're talking now about half reactions and balancing redox reactions. So continuing what we have talked about so far with oxidation and reduction reactions. If you have a redox reaction, you actually have both parts. You have an oxidation half and a reduction half. You're always going to have two half reactions, oxidation and reduction. Remember, oxidation is the process of losing electrons, and reduction is the process of gaining electrons. So, if we're losing electrons, the electrons are going to be on the product side. Reactants, what we're starting out with, lose electrons. So on the product side, what's produced has fewer electrons. Or the substance has fewer electrons. Electrons are given off on the product side. Reduction is gaining electrons, so we have to have electrons on the reactant side. So what we need to do over here is classify the half reactions based on what we just talked about. So we could look at the oxidation numbers, what happens to those. That's what we did on the last one. So I see that I have a +3 and then it becomes just 0. So that looks like it is reduction. Well, we can check. Reduction is gaining electrons, right? Reduction is gaining. With reduction, the electrons are on the reactant side. So all of those things communicate the same thing. This is a reduction reaction. All right, this one, I have 2Br minus, and then I see electrons over here on the right side. That's oxidation. Down here, my electrons are on the product side. That's oxidation. Reactants are on the electrons are on the reactant side. That's going to be reduction again. Gaining electrons, reactant side, that's reduction. Losing electrons is oxidation. All right, so that was a look at how to recognize which is which. Now let's see if we can balance a simple half reaction. The ones that already have electrons shown, can we balance them? Or not when the electrons are shown. We're just going to focus on putting electrons in where they go. First, we need to assign the oxidation numbers so that we can determine whether the half reaction is oxidation or reduction. Balance the elements on both sides of each half reaction. So that means we need to make sure we have the same number of elements, just the way that we normally would balance a reaction. And then we need to balance the charges by adding electrons. Remember, oxidation is losing, reduction is gaining. Oil rig. So oxidation is losing, so the electrons will be on the product side. Reduction is gaining, so they'll be on the reactant side. All right, here are some examples down here. Write the balanced half reaction from the given reactant and product. Well, I have a 0 becoming +2. So we want to know what the difference is between these two. Well, there's a difference of 2. It becomes more positive by 2. Zinc became more positive by 2. So in order to really balance out the charges, I have to have 2 negatives on the product side as well. 2 electrons. Okay, with this, I first have to look at how many of each I have. Well, I have 2 iodines on the left, and then on the right, I've only got 1, so I really need to put a coefficient of 2 right there. Okay, so I have a -2 charge on the right, and I have a 0 charge on the left, on the reactant side. So I need to add some electrons to the left side, because electrons are negative. I have a -2 on the right, I need to have 2 electrons on the left, so that they have the same charge. We're just balancing out charges. I have indium with a 3+ charge. This side, the product side, it's 0. Where could I add electrons to make them the same? That would be on the left side, so I need to put in 3 electrons. And you can also think of it as what's happening. Well, the charge went from positive to more negative. It lost some of its positive charge. It became more negative or less positive. That's reduction, right? So with it being reduction, I need to have electrons on the reactant side. Lots of ways to think through these. Okay, this one's becoming more positive. That's oxidation. So I need to have my electrons on the product side. And I need 2 electrons for my charges to balance out. Positive 4, negative 2 becomes positive 2, which is what we have on the reactant side. All right, that's it for the examples in this video. We'll continue by learning how to balance redox reactions on the next video.